In this video, we are going to see about the problems related to the regular expression. So the first problem, A is a regular expression. If A is a regular expression means we have to represent as a set of A. Set of A means within a curly braces we have to represent. The next one, A plus B is a regular expression. A plus means it is also denoted as the R simple. So it is represented as A comma B. Then AB is a regular expression. So if AB is a regular means we are using the concatenation operator. So it is represented as AB. Then A star is a regular expression. So star means it is a clean closure. So that means it contains 0 or more instance. So it is represented epsilon. So for 0 we are denoting the empty string epsilon. Then 1 times A, 2 times A, then 3 times A and so on. Then A plus B, the star is a regular expression. So it representing all the combination of A's and B's. Okay, it represents all the combination of A's and B's. So here there is a clean closure. So it will represent the empty string also. So epsilon A, B, AB, AAB or BBA, BBA. So these are the some input symbols here. Okay, the next one, A within a parenthesis A plus B star B. So it is denoting all the strings over sigma of A comma B. So it starts with the A and end with the B. So this A and this B is a compulsory. In between this A and B we can have a multiple 0 or multiple instance. So the shortest one is AB. Then we can have A, B, B, then A, B, B. So these are the some example symbols here. Then 0 plus 1 the whole star, 0, 1, 1. It is denoting all the binary strings over sigma 0, 1. It ends with the 0, 1, 1. Okay, so that is it ends with the 0, 1, 1. So this 0, 1, 1 is the shortest string. Other than that, you can have 0, 0, 1, 1, then 1, 0, 1, 1. So like this, so on. Okay. The next one, 0 plus 1 the whole star, 0, 0, then 0 plus 1 the whole star. So it is denoting all the binary strings having a 0, 0 as a substring. So here 0, 0 is a substring. So before and after the substring 0, 0 have, we can multiple number of zeros and ones. The next one, 0 star, 1 star, 2 star. It denotes the string over sigma of 0, 1, 2, 3. So here at least, okay, so here having any number of 0 followed by any number of 1 followed by any number of 2. Okay, so first it should contains only the 0, then 1, then 2. So for example 0, 1, 2 or 0, 0, 1, 1, 2, 2 or 0, 1, 1, 2, 2, 2. So the meaning is it should have any number of 0 followed by any number of 1 followed by any number of 2. Then we will see some more example. Here set of all strings having even number of A's over sigma of A. So here we have to write the regular expression. So what it is given, set of all strings having even number of A's over sigma of A. So it should have even number of A. So how we can represent? We can write A the whole star. A the whole star. Okay, so that means there can be an empty string, then 2 times A, then 4 times A, then 6 times A, and so on. Okay, the next one, set of all strings having odd number of A's over sigma is equal to A. So odd number of A's. So we can write, so first A. Okay, so it should be a constant. A, then A the whole star. So why we are writing A the whole star means if there is a one instance. So if there is a one instance means what will be the symbol, it is A. So suppose if it is a 2 instance means A 4 times A will come. So totally 5 A's. Okay, so it contains the odd number of A's. Okay. The next one, set of strings having even number of A followed by the even number of B. So what will be the input here? What will be the symbol here? A. So that is even number of A followed by odd number of B. So like B 3 times B, or 4 times A then 3 times B, or 4 times A then 5 times B. So this is here in this string, even number of A's followed by the odd number of B's. So how we can write? So we can combine with this. So how we wrote the even number of A? So same thing. So even number of A. So the A the whole star. Then next we have to write followed by odd number of B. So we can add this also. So B then B the whole star. So you can see. So even number of A, B, then B the whole star. The next one, set of all 3-digit binary number. So it should contain only 3 digit. 3 digit means it can be a 0 digit. Binary number means zeros and ones, right? 0 or 1 or 1 0 1. So it should contains like this. So we can use the OR operator. 0 plus 1, then 0 plus 1, then 0 plus 1. So here 0 or 1, 0 or this is also 0 or 1, 0 or 1. So it always contains 3-digit binary number. The next one, strings starting and ending with A have only B in between. Okay, so that is string starts with the A and end with the B. End with the A and in between it should contains only the B. So what will be the symbols here, like A B A or A B B A or A B B B A. So how we can write? So starting symbol is A and ending symbol is A. In between B we can have multiple number of in between A we can have multiple number of B's. So A star A, B star, A. Okay. Then set of all strings over sigma A comma B in which the total number of A is divisible by the 3. Okay. The total number of A is divisible by the 3. So total number of A is divisible by the 3 means how we can have B or B A. So like this way. So how we can write? Um, we can write like this. 3 times there should be a. Okay, so it is a common. So then what we can do, in any places, all the places we can give like this. B star, then here also B star, then B star. So if you need 6 A's means what we can do? We can use the clean closure here. So that is B star, A, B star, A, B star. Then set of all binary strings of length 3 or less. Okay. Set of all binary strings of length 3 or less. So we can give 0 plus 1 plus epsilon, or 0 plus 1 plus epsilon, and 0 plus 1 plus epsilon. Okay. So the length will be less than the 3 or less. So if you are considering here epsilon and 0 1 means it is less than the 3, right? So we can take 0 1 1 0 1 1, then 1 1, then 0 0 1 0 0 triple 1, then 1 1 0 0. These are the symbols. The next one, set of all strings over sigma A comma B that do not contains the substring AB. So it should not contains the substring AB means what we can do? First we can mention the B. So substring AB, so it should be BA or BBAA or BAA. So what we can do? First we can mention the B. So B star, A star. So it contains only first it contains only the B. The next one, the regular expression is given, so we have to give the description for that regular expression. So here first one is a plus ab the whole star. So a plus ab the whole star means, what is the meaning? For this whole star, clean closure is there, so there can be a epsilon. Okay, empty string is possible. Then it can have only the a. Okay, only the a, or it can have a b, or sorry, a b, or a b, or a b a. Okay, so how we can represent this? It represents set of all string over sigma a comma b. It starts with a and having no consecutive b. Okay, the meaning is it start with a and having no consecutive b's, not having consecutive b's. So that means we can give like this also, a b a b a should not contain the consecutive b's. The next one, b star 3 a star b star. Okay, so here how we can represent, whenever we are using the a, a should be appear 3 times. So here meaning a star. So once it is an empty string, if it is not an empty string, always it contains the 3a's, triple times of the a. So what will be the symbols here? So there is a possible for the empty string because there is a clean closure, and for this, if you are applying the empty string, means only b can be there. Then there will be 3a's. Then 2b is also possible if it is a empty string, means for this 2b, so bb is also possible. Then b a b is possible. Then b b a, always the a is always appear triple times. So here what is the description? We can write always, sorry, always a appears triple times. Okay, the next one, 0 plus 1, 0 plus 1, 1, 0 plus 1 the whole star. So what is the meaning? Here first it can be a 0 or 1, and here there is a 0 or 1, and next third is a 1, then last one 0 plus 1 the clean closure. So it can be a 0 or a empty string, right? So what can be the input? 0, then for this 1, then 1. So this is possible for if we are considering this as a empty, so 0 1 1, then or 0 1 1 1, or 1 1 1 0. So you can see always third digit is 1 because of this 1. Always third digit is 1. So how we can write set of all binary strings whose third digit from left should be 1. Third digit from left should be 1. The next one, 0 plus 1 the whole star, 0, 0 plus 1 the whole star, 1, 0 plus 1 the whole star. So it is same as the previous example. So here you can see the 1 is a constant, we can't change, we can't alter this. Then 0, this 0 also. Okay, and here there is a clean closure, so we can't consider like this. So what we can do, from the right we can consider the position. So before that we will see what are the possible symbols here. So here 0 plus 1 the whole star. So here possible for the empty or 0 or 1 instance, 0 or more instance. Okay, so first, so I'm taking this as an empty string. So here 0 is here 0. Then for the 0 plus 1 we have to consider any value 0. then this one also constant 1, then 0. So suppose if it is not an empty string, we can say 1 0 1 0, then 1 0 0 1 0. So you can check here from the right side, from the right, the second is always 1 and fourth is always 0. Here see, second is always 1, fourth is always 0. So we can write this as set of all binary strings whose second bit from right is 1 and fourth and fourth bit from right is 0. The next one, 1 plus 0 1, the whole plus. So here whole, the plus means it is a positive closure, right? So positive closure means it contains one or more instance. Clean closure means it is 0 or more instance, and here 1 or more instance. Okay, so what can be a input symbol? So only one can be there, or this one, only this one can be there. Next only this 0 1, so 0 1, or 4 times 1, or 0 1 0 1 0 1. Okay, so here how we can write the statement, set of all binary strings that end with 1 and having no consecutive zeros. Okay, set of all binary string that end with 1 and it doesn't have no have consecutive zeros.